SARS-CoV-2 has been infecting humans for only a few months now, and the disease it causes, COVID-19, has spread worldwide. Let's take a look at the basic mathematics behind an epidemic and what doctors mean when they say flattening the curve. The basic epidemiological model used by mathematicians is the SIR model. The population is divided into three compartments: susceptible, infected, and recovered. Here, we assume that once a person has recovered, they are immune to reinfection. This model uses an area of math called calculus. In calculus, we describe rates of change. In this case, we want to know how the number of infection changes with respect to time. To do this, we want to satisfy this set of differential equations. In these equations, beta can be thought of as the probability of a single person infecting one other person per day, and 1 over gamma is the number of days one person stays infectious. R0 is an important metric when tracking an epidemic. Its full name is the basic reproduction number, and it tells us how many people a single person is likely to infect over the course of their illness. We can express R0 in terms of beta and gamma. Don't let these equations or Greek letters intimidate you. It becomes a lot easier to understand when we look at the graph. Let's see what these equations tell us. The y-axis is a count of the number of people and the x-axis is time, given in days. Once a person becomes infected, they are no longer part of the susceptible population, so that number decreases over time. As people recover from the infection, they join the recovered population and are immune to reinfection. The infected population is where we're having the most trouble. We see an area of exponential growth, a peak, and a drop-off. Here we run into one of the major issues with COVID-19. An estimated 15% of cases require hospitalization. We can track this number throughout the infection period. Ideally, there are enough medical resources to support all the people that need it at the peak of an infection. What we've seen in places like China and Italy is a massive amount of strain on their healthcare systems. Now that we know the basic math behind an epidemic, we can take data-driven actions in order to lower the impact of COVID-19 on our society. The R0 value holds part of the solution. Watch what happens to the infected and hospitalized curves when we lower the R0. This is what doctors are talking about when they say flattening the curve. By practicing good hygiene habits, social distancing, and if necessary, isolation and quarantine, we can lower the R0 value. We are effectively spreading out the infection over a longer period of time, leading to a healthcare system that can handle the load. This means that we will have sufficient resources available to look after those who become severely ill. In a pandemic situation, each of us plays an important role in our health and the health of our neighbors. Think about how these mathematical concepts affect you and your community and make informed decisions on what actions are needed. We're 2 decades into the 21st century. Our actions don't need to be governed by fear and panic, but rather by data, wisdom, and a little bit of common sense. Thank you for watching and stay healthy.